Okay, in this final segment of hypothesis testing using SPSS, we're going to take the SPSS file that we've created and explored earlier, and we're going to finish the assignment. Now, the first thing we want to do is we want to set up a Word document, and I've got one set up here. And I'm going to give a very brief description first of what I've done, where I got my data, where you can find more information about it, and I'm also going to describe the variables I've used in the assignment and how I transformed them. This was in the last session. Now, predictions. I'm going to predict that dropout rate will differ by school type, with high schools having the highest dropout rate. I'm going to predict that free and reduced lunch percentage will differ by dropout rate, with higher dropout rates having a larger percentage of free and reduced lunch students. I'm going to predict that elementary schools will have a higher percentage of Hispanic students, mainly because I believe that there are more younger Hispanic students than older Hispanic students. I also predict that the relationship between total points possible and the percentage of free and reduced lunch students will be negative. That is, the greater the percentage of free and reduced students, the lower their total score will be. Okay, so first I pull up my SPSS file, and I will do the first one, the chi-square first, that is the dropout rate by school types. And what we'll do is we'll take this prediction and we'll paste it in our chi-square. Pulling up the SPSS file, we're going to go Analyze, Descriptive Statistics, Crosstabs, and we're going to do school type by dropout rate. We're going to want the chi-square statistic, and in order to make everything a little bit easier to interpret, we're going to ask for row percentages. And clicking OK, we get our results. And the first thing we're going to look at is the chi-square and the significance of the chi-square. And we find that this is not statistically significant because the value of the chi-square, the significance level, is greater than 0.05. So we need both of these tables. So we're just going to copy, go to our SPSS output. We'll take our crosstabs first, copy it, back to our Word document, and we're going to paste it. Back to our SPSS. We're going to copy, back to our Word document, and paste. What we find, it's not statistically significant because the significance level is greater than 0.05. So we retain the null and the alternative and say we did not discover any effects. Now we note here that the dropout rate for elementary school is a little bit higher than the dropout rate for middle school and high school, opposite of what we predicted. But it's not statistically significant. So we have to say we did not find a relationship between school type and dropout rate. And we could comment if we wanted to that our results were in the direction opposite of what we predicted, but we won't right now. For the t-test, we're going to do the dropout to look at the free and reduced lunch percentage will differ by dropout rate. And again, we're going to look at dropout rates. We'll go back to our SPSS data file. And this, to do our t-test, we'll go Analyze, Compare Means, Independent Samples t-test. Our test variables, our dependent variable, will be free and reduced lunch percentage. Our grouping variable will be dropout rate. And we define the groups as group 1 is 0 and group 2 is 1. Continue. OK. And here's our data. Again, like before, what we'll do is we'll take our means back to our output, paste our means. Actually, let's take the t-test and put that on a separate page. So we find, just looking at our means, we find a fairly large difference in the percentage. Note that there are a lot more lower than high dropout rate schools, but that the high dropout rate schools have a very high percentage of free and reduced lunch. So going back to our, before we do our t-test, what we'll do is we'll copy our prediction. Paste it there. And we'll go back to our output. And paste it. And this is going to be way too big. We'll see if we can reduce the size of this. Okay, we're going to auto fit the contents. And we'll clean this up just a little bit. Okay. What we'll do is we can make this 8 points. Make it really hard for me to read. But at least we can see what we've got. We have it all on one page. So looking at this, and this is very often where students make a mistake, because the significance level we're looking for is the significance level of the two-tailed test. It's this value right here. And we find the significance level is 0.00. There's some number out here, but certainly this is less than 0.05. So it is statistically significant. and we reject the null hypothesis and say we found real effects because, again, it's less than 0.05, and the results were as predicted. The next thing we're looking for is elementary schools will have a higher percentage of Hispanic students. Next prediction we're going to look at, and that'll be our ANOVA prediction. To do that, we'll go back to our data file. We'll look at Analyze, Compare Means. We'll use the means. The dependent list will be the Hispanic percentage. The independent list is the school type. So the dependent measure is Hispanics. The independent is school type. We're only going to do one. We'll select options, and we're going to select ANOVA table and ADA. And then we'll simply hit OK. And here are our results. We don't really need the case processing summary. That really doesn't tell us that much. We are going to click on the report, copy. We're going to go back here, paste it. Looking at our results, we find that elementary schools, in fact, do have a higher percentage. The percentage is rather low. I mean, it's about 5%, 4.81% overall. And the elementary schools have 5.10. So there's not a lot of difference, but there is a difference, and our ends are fairly large. So looking at our results, and let's put this on a separate page. Looking at our statistical significance, again, now we're going to look at our ANOVA table. And let's put this. Again, we'll auto-fit it so we can see everything. When students have things having tables hang over the edge, it makes it really hard to read. And we can do that to make it a little bit easier. We find that the F is 4.194 with a significance level of 0.015, which again is less than 0.05. So it is statistically significant. And we can just copy what we said before. It is statistically significant, that is, we reject the null, accept the alternative, and say we found real effects. And again, we'll put the correlation coefficient on yet a separate page. And going back, we'll copy the prediction. And going back to our output, our data file. Going back to our data file, we'll go to correlate, bivariate, and put percentage points and free and reduced lunch. We don't really have any options or anything. We don't need them. We'll just say OK. And copying that, going back to our output. Our correlation is minus 0.411. Again, it is statistically significant. There's some number out here, but it doesn't show up. It's certainly less than 0.05. It's less than 0.01. So again, it is statistically significant. We reject the null, accept the alternative, and say we found real effects. The results were as predicted. Now with this one, we're going to go just a little bit further, and we're going to, if we're going to do this, we might as well explore the data, and just giving the correlation coefficient is somewhat useful, but it's much more useful if we can draw a picture. And we'll take a simple scattered plot. We'll define it as the percentage of the points in the y-axis and free and reduced percentage on the x-axis. And there's our graph. We could edit this if we wanted to, but we're just going to copy it and paste it into our output. And this lets us explore the data a little bit, explore the relationship in a lot more detail than just the numbers. We see that there is a negative regression line, a negative slope. We also notice a few things. We notice that we've got some data over here with a free and reduced percentage of 0. And looking at this and looking at our trend in our data, my guess is that this might not be real data. If I were doing this for a project, I would go and look at these 5 schools with free and reduced lunch percentages of 0 and look at them in some detail. And looking at this data, we find that some schools that have a very high free and reduced lunch percentage actually score quite high. There's a lot of variability here. And we note that there's not much variability when you have a free and reduced lunch percentage of less than 20%. There's not much difference. And looking at this data, what I would think is that there's what's called a ceiling effect. That is, a lot of schools get 100%. If we didn't have the ceiling effect, we would probably have data that look like this, and the relationship would be much stronger between free and reduced lunch and the total percentage, the percentage of total points that they get. But that's what looking at the scatter plot can tell us. It can tell us a lot more. So we're going to use the correlation coefficient kind of as an indicator of things we might want to look at. So we're all done. We're going to file. We're going to save this. And our assignment is complete.